Coal swamps, sometimes called coal forests, were broad areas of low-lying swamp that existed during the Carboniferous and Permian periods. Today we will explore this magnificent and incredibly ancient ecosystem. The flora of these swamps generally consisted of large lycopsid trees, such as Lepidodendron and Sigillaria, ferns, giant horsetails, and seed plants. The fauna consisted of large arthropods like giant millipedes and dragonflies, early amphibians, and amniotes, the precursors to today's birds, mammals, and reptiles. These swamps were restricted primarily to the tropics, as Earth was in an ice age during the time. Though later on in the Permian they would have been able to form farther out in higher and lower latitudes due to the climate warming. These swamps are named for the abundance of coal in Carboniferous-aged rocks. This coal was formed when dead plant matter went untouched by bacteria and fungi, as the rate at which these plants grew and died, as well as the sheer abundance of plants at the time, led to an overaccumulation of dead undecayed plant matter. This matter formed layers of peat, which are oxygen-poor. This oxygen-poor environment provides the conditions for this matter to be fossilized and eventually become the coal that humans use for energy today. Among the most common plants in this ecosystem was Lepidodendron, a tall tree like lycophyte. These trees could reach over 30 meters, or 100 feet in height. The majority of their life they would have had the appearance of a tall branchless green trunk, and as they reached maturity they would branch out into a crown at the very top, where they would develop cones and disperse spores. They lived on average 10 to 15 years, possibly dying after reproduction. Ferns and horsetails would have been a large bulk of the plant life in these forests. They would have been some of the primary ground-covering plants, similar to grass today. However, there were some that grew in a tree-like manner. The seed plant groups in these swamps primarily consisted of seed ferns, a polyphyletic group of different plants, and early gymnosperms, relatives of conifers, ginkgos, and cycads. The dominant group of plants in these wetlands were lycophytes, also known as club mosses. They ranged from tall trees to small climbing plants. They reproduced via spores, like their extant relatives. The closest living relative to the lycopsid trees of these swamps is Isoetes, a small aquatic plant. Amphibians were among the most numerous groups of vertebrates in these forests. The largest of this group were the temnospondyls, which were more well adapted to live on land than other groups of amphibians at the time, and even compared to the amphibians of today, though they still had to lay their eggs in water or damp and moist areas. Stegocephalians are relatives to the amphibians and amniotes. These animals were generally more fish-like than their relatives. Some, like the Astopodons, had snake or eel-like bodies. Some, like Lepospondyls, had large arrow-shaped heads, and were salamander-like. These animals could possibly belong to the class Amphibia, but this is contested. They would have been semi-aquatic, and spent large amounts of time in bodies of water, like rivers. Amniotes first appeared in these forests. They were the first vertebrates to fully adapt to a terrestrial life, having thicker skin to hold in moisture, and being able to lay eggs without the threat of them drying out. Reptiliomorphs are the closest relatives to the amniotes. Some have characteristics of amphibians, while others are more like that of true amniotes. Some of these animals could possibly belong to the group Synapsida, Sauropsida, or Amphibia. Early synapsids were among the largest animals in these forests. They dominated these swamps at the end of the Carboniferous and continued to be a main component of the ecosystem far into the Permian. They mainly consisted of Edaphosaurids, Archaeocodonts, Caesiids, Varanophids, and Sphenacodonts. The Sphenacodonts in particular being one of the closest related groups to mammals. These animals would have been reptile-like in appearance, though they were not reptiles. They would have had a sprawled posture and scaly skin, along with being cold-blooded. They didn't give birth to live young like their distant mammalian relatives, instead they would have laid eggs. Early sauropsids were smaller animals similar to modern lizards. They consisted of the earliest diapsid reptiles and parareptiles. Myriapods were among the earliest terrestrial animals. They include modern-day millipedes and centipedes, which also existed in the coal swamps. The largest terrestrial arthropod to have ever existed, Arthropleura, belonged to this group. It was a millipede, and probably the largest animal of these swamps. They were most likely herbivores feeding on things like nuts and dead plant matter. Their size could possibly be attributed to the high amount of oxygen during the time, but a specimen dating to the early Carboniferous, where the atmosphere was less potent in oxygen, puts this into question. Insects thrived in these swamps, including rochoids, the ancestors of roaches, termites, and mantises, and Meganizeropterans, large relatives of dragonflies and mayflies. Meganizeropterans were the largest insects to have ever lived. They could have wingspans of over 30 centimeters, or 11 inches. Arachnids inhabited these swamps, including scorpions and the very first true spiders and various spider-like arachnids. Some of the scorpions were among the largest arachnids to have ever lived. The immense number of plants in these wetlands caused some of the highest levels of oxygen in Earth's history. This high oxygen environment caused fires to be uncontrollable and catastrophic. The climate would have been high in humidity and tropical. Lycophytes were the main trees in wetter areas, while seed plants were the main trees in drier ones. These swamps would have formed in lowland areas. The coal swamps were greatly reduced in the Carboniferous rainforest collapse 305 million years ago, a minor extinction event caused by the climate of Earth becoming drier and cooler. These swamps didn't completely die off, however. They survived into the Permian, in the landmasses of Cathasia and Gondwana. However, the last remnants of these once mighty forests were destroyed at the very end of the Paleozoic, when 90% of life on Earth met a grisly demise in the Permian Triassic extinction.